Hi all, welcome to new class. Today's class is about sign of trigonometric functions. So let us go through the class. Let P a comma B be a point on the unit circle. So this is unit circle, that is radius is 1 unit. Then with the center at the origin, such that angle AOP is equal to x. So here angle AOP is equal to x, and if angle AOQ, that is angle AOQ, is equal to minus x, then the coordinates of the point Q will be a comma minus b. So here we can write cos minus x. So cos minus x will be adjacent side divided by hypotenuse, that is, and which is equal to cos x, that is cos x is also adjacent side divided by hypotenuse. So cos of minus x is equal to cos x here, that is cos x is a divided by 1. Here also cos minus x is a divided by 1. And if we take sine of minus x, so first of all sine x is opposite side divided by hypotenuse, that is b divided by 1. Then sine of minus x is, this is minus b, so minus b divided by 1. So we can say sine of minus x is equal to minus sine x. And the signs of all the trigonometric functions are, so this is first quadrant, then second quadrant, third quadrant, fourth quadrant. In first quadrant all the functions are positive. In the second quadrant sine functions are positive, all others are negative. In third quadrant tan functions are positive, all others are negative. Then in the fourth quadrant cos, that is cosine functions are positive and all others are negative. All functions means sine, cos, then cosec, sec, tan, cot, all are positive in this first quadrant. Then in the second quadrant sine and cosec, sine and its reciprocal cosec are positive and all others are negative. Then in the third quadrant tan and cot are positive, that is tan and its reciprocal cot are positive, all others are negative. Then in the fourth quadrant cosine, that is cos and its reciprocal sec are positive and all others are negative. So sine x is positive in the first and second quadrants and negative in the third and fourth quadrants. Then cos is positive in the first and fourth quadrants and negative in these quadrants. So like all the functions we can define. Let us do a problem. If cos x is equal to minus 3 divided by 5, x lies in the third quadrant, then find the values of other 5 trigonometric functions. So here cos x is given as minus 3 divided by 5. So we can write its reciprocal sec x is equal to minus 5 divided by 3. Now we have sine square x plus cos square x, that is we know this identity sine square x plus cos square x is equal to 1. From this we can write sin square x is equal to 1 minus cos square x, that is 1 minus 9 divided by 25, and that is equal to 16 divided by 25. So sin x is equal to square root of 16 divided by 25, that is plus or minus 4 divided by 5. And it is given that x lies in the third quadrant. So in the third quadrant, sin is negative. So we can write sin x is equal to minus 4 divided by 5. So from this we can write cosec x is equal to its reciprocal, that is minus 5 divided by 4. Now we have to find tan and cot. That is, we know tan x is equal to sin x divided by cos x, that is sin x is minus 4 divided by 5, then divided by cos x is minus 3 divided by 5, that is 4 divided by 3. So we can write cot x is equal to its reciprocal, that is 3 divided by 4. So in the third quadrant, tan and cot are positive. All the other functions are negative. Next is trigonometric functions of sum and difference of two angles. We have sine of minus x is equal to minus sine x, and cos of minus x is equal to cos x. And we know the identity cos of x plus y is equal to cos x cos y minus sin x sin y. Also cos of x minus y is equal to cos x cos y plus sin x sin y. Using these identities, we can find cos pi by 2 plus x and cos pi by 2 minus x. That is, cos pi by 2 minus x can be right cos pi by 2 into cos x plus sin pi by 2 into sin x, and that is equal to cos pi by 2 is 0, then 0 plus sin pi by 2 is 1. So this is equal to sin x. So cos pi by 2 minus x is equal to sin x. Similarly, cos pi by 2 plus x is equal to cos pi by 2 into cos x minus sin pi by 2 into sin x. So here we get a minus sin x. So cos pi by 2 plus x is equal to minus sin x. And we have the identity sin of x plus y is equal to sin x cos y plus cos x sin y, and sin x minus y is equal to sin x cos y minus cos x sin y. So from using these identities, we can find sin pi by 2 plus x, that is equal to sin pi by 2 into cos x, then plus cos pi by 2 into sin x. So this is 0. So we get cos x. That is sin pi by 2 plus x is equal to cos x. Then sin pi by 2 minus x is equal to sin pi by 2 into cos x minus cos pi by 2 into sin x, and this is equal to 0, and that is equal to cos x. That is sin pi by 2 minus x is equal to cos x. So sin pi by 2 plus x and sin pi by 2 minus x is equal to cos x. Similarly, we can find cos pi minus x. So cos pi minus x is cos pi cos x plus sin pi sin x. So here sin pi is equal to 0 and cos pi is minus 1. So we will get minus cos x. And next is cos pi plus x. So in cos pi plus x is, it will be cos pi is minus. So here also we will get a minus cos x. So cos pi minus x and cos pi plus x is equal to minus cos x. Similarly, sin pi minus x is, sin pi minus x is here. That is sin pi cos x minus cos pi sin x. That is sin pi is 0 and here cos pi is minus 1. So minus of minus we will get a plus, that is plus sin x. So it is sin x. Then next is sin pi plus x. So sin pi plus x is sin pi cos x plus cos pi sin x. So this term will be 0 and here cos pi is minus 1. So minus of sin x. Similarly, we can find the values for cos 2 pi minus x. So cos 2 pi minus x is here cos 2 pi, then cos x, then sin 2 pi is 0. So cos 2 pi is 1. So we will get a cos x. Then next is cos 2 pi plus x. So in cos 2 pi plus x, it will be, here it will be 0. So cos 2 pi is 1. So here also it will be cos x. Then next is sin 2 pi minus x. So in sin 2 pi minus x, it will be here sin 2 pi. So this one will be 0 and here it is cos 2 pi sin x. So cos 2 pi is 1. So we will get a minus sin x. Then next is sin 2 pi plus x. So in sin 2 pi plus x, this one will be 0 and here it is cos 2 pi into sin x. So cos 2 pi is 1. So we will get sin x. Let us do a problem. Find the value of sin 31 pi divided by 3. So to find this value, we know sin 2 pi plus x is equal to sin x. That is, the value of sin x repeats after an interval of 2 pi. So we can write sin 31 pi divided by 3 is equal to sin 10 pi plus pi by 3. So sin 10 pi plus pi by 3. That is, it is like sine 2 pi plus x. So this one we can write sine of pi by 3, and that is equal to root 3 by 2. Sine pi by 3 is root 3 by 2. So in this way we can do the problems if we know the values of sine and cosines of each quadrants. And using the quadrants we can easily identify these values. That is cos pi by 2 minus x, that is x lies in this region. So cos pi by 2 minus x, that is cos is positive in this region, and if pi by 2, then opposite function we have to take, that is cos. If this is cos, then sine. So sine x, that is cos pi by 2 minus x is equal to sine x, and which is positive in this first quadrant. And here this is cos pi by 2 plus x. So this is pi by 2. So we have to take a sine. Then to know the sine, cos pi by 2 plus x. So x lies in this quadrants, that is second quadrant. So in the second quadrant this cos is negative, so we have to put negative here. Then for the value of sine pi by 2 plus x, so sine pi by 2 plus x is here, so sine is positive here, so positive. Then sine pi by 2. So if this is pi by 2 or 3 pi by 2, then if this is sine, then we have to write a cos here. Then for cos we have to write a sine here. So this is pi by 2 plus x, and that lies in this quadrant. So we have to write a cos x. Then next is sine pi by 2 minus x. So sine pi by 2 minus x is in this quadrant, and in this quadrant sine is positive, so we have to write cos x. Next is cos pi minus x, and here if this is pi or 2 pi, then the same function we have to write here. So this is cos pi minus x. So cos pi minus x means that angle lies in this quadrant, and in this quadrant cos is negative. So we have to put a negative sign here. Next is cos pi plus x. So cos pi plus x is in this quadrant, and in this quadrant cos is negative. Next is sin pi minus x. So sin pi minus x is in this quadrant, and in this quadrant sin is positive. So we have to write a sin x. Then sin pi plus x. Sin pi plus x is in this quadrant. In this quadrant sin is negative. So we have to write a minus sin x. Next is cos 2 pi minus x. So cos 2 pi minus x is here, and in this quadrant cos is positive. Then cos 2 pi plus x is in this quadrant, and in this quadrant cos is positive. Then sin 2 pi minus x is here, and in this quadrant sin is negative, so we have to write a minus sin x. Then sin 2 pi plus x is here. Here sin is positive, so sin x. So if this is, that is cos pi by 2 or sin pi by 2, then if this is cos, then we have to write a sign here, and according to the quadrant we have to take the sign. And if this is pi or 2 pi, then the same function we have to write it, and sign according to the quadrants we have to write. So that is about the signs of trigonometric functions in different quadrants. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.